Hi students, we're going to continue our work on conic sections by looking at the ellipse. Now this ellipse is a set of all points on a plane where the sum of the distances, not bad, to the foci is constant. Now the foci is actually plural for focus. So there's a focus here and there's a focus there, guesstimating where they are. And what they're saying in the statement is if you connected this foci to this foci by rebounding off the side, let's say that this distance was 6 and this was 6 for a total of 12. No matter how you connect those 2 points, if you rebound off the side, it's going to be 12. Like that might be 2 and 10 or 1 and 11. But no matter how you rebound off the side, those 2 distances will be constant. So that's what they mean by that statement. That's how you define an ellipse. Now, there's some important equations I want you to see here, and this is the standard form. Notice the difference. They're both x minus h quantity squared plus y minus k quantity squared equals 1, but one of them, notice, has an a squared under the x, b squared under the y, where conversely, now under the x you have the b squared and the a squared is under the y. I think of the a as like the alpha. It's the bigger number. If the bigger denominator is under the x, your major axis is horizontal, so it'll be a wider ellipse. If your a or alpha or the bigger denominator is under the y, your major axis is vertical. And that's important because what the deal is your foci are on the major axis. And so are your vertices. It's a weird, it's a little bit different than what you're used to. And I'm going to show you that, a drawing where I draw that out for you in just a moment. And so here's, the h and the k are of course the center, not to be mistaken with the vertex. Here, if it's at the origin, it just looks, they've just taken the minus h and minus k out. All right, let me show you what I'm talking about. Now these drawings show a center, hk, and that is the role of a center, to be right in the middle. But I actually, and you can take this picture if you want, I actually look at it a little bit differently, if you will permit me to show you. Let me use something with values. Okay, let's say that I needed to find all the critical points, it shouldn't be called critical points, important attributes of this ellipse. I know that, first of all, I know this is an ellipse because x and the y are both squared. This equals 1, and they have 2 different denominators. If they had the same denominator or the same coefficient, then it's growing as wide at the same rate as it's growing long. So that'd be a circle. But this one is actually getting longer than it is wider, faster. That's poorly said. Let me show you. First of all, the first thing you have to do is find the center. And the center here is your hk. So hk is your center, and in this case, it's going to be 0, 0. So I like to kind of draw it. You'll see in a second why. Okay, and now I need to find the major axis. To find the major axis, it's whatever denominator is bigger. So in this case, this 9 is my a squared. Now bear in mind, this is the equation I'm looking at right here. So it's a vertical, since the bigger number is under the y, the major axis is vertical. But this is a squared. The distance you're going to come off this center is your a. So it means from 0, 0, it's going to go up the square root of 9, which is 3. So it's still going to be 0 on the x, 3 on the y, and then go down 3. 0, -3. These are called my vertices. So if this is my center, my vertices, which shows how which are at the end, like here's a vertex here, here's a vertex here, here's one here, here's one here. So add this to your notes right here. The HK is your center, and the vertices are the endpoints of the major axis. So here's my vertices, which is 0, 3, 0, negative 3. Now I'm going to find the co-vertices. And as stated right here, these points, the co-vertices are the endpoints of the minor axis. Now to find the co-vertices, I need the b term. 4 in this case is b squared, but I just need b. And b is 2. That means it's going to go sideways 2 in each direction. So this will be negative 2, 0, because it's going to go 2 to the left and 2 to the right. So there are my co-vertices. So I'm going to put CV for co-vertices, negative 2, 0, and 2, 0. Now I need to find the two focus points called the foci. Now to find the foci, you have to do a squared minus b squared is equal to c squared, but the foci is a c. So I'm going to take the 9, which is a squared, minus the b squared, which is 4, and I get 5. So in this case, c squared is equal to 5. Therefore, c is equal to the square root of 5, which I'm going to put as 2.2. Okay? So here's what you do with the foci. The foci is going to be on the major axis. And it's actually going to be between the vertex and the center. So from the center, staying on that major axis, you're going to go up 2.2. I'm going to do this in a different color. So it's still on the 0, but it's 2.2, and then down 0, negative 2.2. So there's my foci, 0, 2.2, 0, negative 2.2. And so notice that the foci is part of the way there. That's how you find what we call the eccentricity. The eccentricity is actually this value of c over a. It's this distance here divided by this distance here. So in this case, it would be the c is 2.2. The a is the square root of 9 in this case. So there is my eccentricity. Now, here's the deal on the eccentricity. It's a number between 0 and 1, and the closer to 0 it is, the rounder, which makes sense. Close, see, 0 is round. So closer to 0, the rounder, and the closer to 1 it is, the longer it is. So write that down. So let me give you a new diagram with how this looks. If this is my ellipse, and my foci is here and here, my center's here, and the vertices are here, co-vertices here. I want to show you what A and B are. The distance on the major axis from the center to an endpoint is your A. The distance from the center to the co-vertice right here, that is your B. And remember, this is the big number is A squared, this is B squared. And the distance from the center just to your foci, that is your C. Okay, I'll do another video with more examples, and you guys take care.